matematika. Today we're going to do problems and solutions of 2.2 change in linear and exponential functions. We'll start with question 1. Two objects are depreciating in value as shown in the table below. So in this table we have the number of years 0 to 4, and there are two objects, object A and object B. First, letter A, determine whether each object is decreasing, each object, linearly or exponentially. So we have to check on the linear function or the exponential function. So using these two functions, whether they are decreasing. So remember that a linear function has a constant rate of change, whereas the exponential function has a constant percent rate of change. So we need to determine if the values of each object has or have a common difference or a common ratio. So we're going to start. Let's observe the first three values of each object, whether its object are decreasing or decreasing by different amounts. Okay, so I'm gonna start with object A. So I'm gonna start with 6,000 minus 7,500. So I will get the difference, and that would be equals to a negative 1,500. How about 4,800 minus 6,000? Okay, 4,800 minus 6,000. That is a negative 12,000. Okay. Now we can see now the difference from three observation, the first three values. How about the second object? So let's say object B. So in object B, 9,000 minus 12,000. So it has a difference of 3,000. How about 6,750 minus 9,000? The difference is 2,250. So can you see a common difference there? We don't see that. So in other words, this means that neither function is linear. So not linear. Okay. Let's check the whether it's exponential. So in exponential, we are going to find the ratios of the amount. So let's say object A again, and it is a ratio. So let's get the ratio by dividing 6,000 divided by 7,500, because we are getting the ratio. So by dividing, you have 0.8. How about 4,800? And then you divide it by 6,000. You have a 0.8. Let's have another one. 3,840. It's the third, divided by 4,800. Then we have a 0.08. So the values do have a common ratio. Okay? And if we try to look at the ratio, so object A differentiates exponentially. Okay, so there is a common ratio, and that ratio is 0.8. So let's look for the object B. So for object B, we have 9,000. We divide by 12,000. And that would become 0.75. Then 6,750 divided by 9,000. Then we have 0.75. Then we have 5,062.5 divided by 6,750. So we have a 0.75. So if we look at also in object B, they have a common ratio. And the common ratio here is 0.75. So what have we observed? That the output share a common ratio. So both object A and B, okay, we say object B, both functions are exponential. So that means since it's depreciating, right? So it is decreasing exponentially. Okay. So this is decreasing exponentially since they are an exponential function. Okay. So it's not being asked what's the exponential function. If we try to look at the exponential decay, since it's decreasing, so might as well we could say the object A. Okay, I will just have it here. It has an exponential decay of, let's say, 7,500. That's the first one, right, in object A. Then you multiply with the ratio, which is 0.8 raised to the x power. For object B, this is y. I have double equals here. Might as well I use the colon. Y equals what's the first 12,000 before it depreciates, and the ratio, common ratio, is 0.75 raised to the x. These are the what we call the exponential decay, since it's decreasing. All right, I have no more space over there. Describe the rate of change of each object. Okay. Since we already know the constant factors of the exponential functions that model the decay, but let's describe the rate of change as a constant percentage. Okay? So we say constant percentage would be the decay rate that should be equals to 1 minus the decay factor. Actually, that should be the case when we talk about exponential decay. So, the decay factor of object A, is the decay factor of object A is 0.8. So the decay rate is, so what will be the decay rate here? The decay rate is 1 minus 0.8, which is 0.2. Multiplying that by 100%, by multiplying that by 100, that would give us 20%. Okay? The decay factor of object B, let's go to object B. Object B is 0.75. So the decay rate, I will write it here. I would emphasize that as decay rate. So here, the decay rate, which is R, is equals to 1 minus 0.75 is 0.25 times 100 to get the percentage. And that would be 25%. So object differentiates. So object A depreciates by how many percent? 20%, while the object B depreciates by 25%. Okay, that's it. Determine which object will have a higher value after 10 years. Okay, that would be after 10 years. So, both functions are decreasing at a decreasing rate. However, the function with the lower percentage will decrease lower than the function over the time. Since object A only loses 20% of its value each year, while object B loses 25% of its value each year. So object A, object A will decrease lower because it's just 20%. This means object A have a higher value after 10 years. So let's check. So object I think I'm gonna write object B, and write it again. Object A only loses 20% of its value each year, right? Value each year. Well, the object B loses 25% of its value each year. So it's very visible that the more percentage you lost compared to the other one who has a small percentage losses for each year, then you could tell which one will have a greater, higher value after 10 years. So we could answer we could say that, let's say, object A, therefore, will have a y equals 7,500 times 0.8 to the power of 10. I'm going to use the calculator here. 0.8 to the 10th power times 7,500. So approximately you have 805.31. That's the value after 10 years. For object B, y is 12,000 times 0.75 to the power of 10. So let's say 0.75 to the power of 10 times 12. That would be 675.76. Okay? Okay, let's do this. A function has the following coordinate. Could the function represent a linear function, exponential function, or neither of the two? So we are given three coordinates here. So in a coordinate, this is x and that's y. So we have three. That would be x sub 1, y sub 1. But actually, if they are written in a manner of a table, you could have x and then you have y. So this would be, if this is negative 2, this is 5. If this is negative 1, this is 8. And if this is 0, then you have 11. So in other words, we try to check if it is linear by getting the difference. Okay? So 8 minus 5, that would be 3, a positive 3. 11 minus 8, that would be 3. Right? 8 minus 5, 11 minus 8. If you do that without converting it into a table. So they have a common difference of 3. And it's common. That means common difference of 3. Therefore, this is linear. So if it's linear, it cannot be exponential because it's linear. Okay, for number 1. So this is a linear function. So let's do the third one. So we do the same thing. 12 minus 10, you have 2. Then 8 minus 12, you have negative 4. So they are not, this one is not linear because they have no common difference. So let's get the ratio So the ratio would be 12 divided by 10. That would be reducing 6 over 5. Here we have 8 divided by 12. That would be by 4. It's 2 over 3. So no common ratio. So no common ratio, it's not quadratic. Sorry. Why am I thinking quadratic? Not exponential. Okay? So if it's not, then this one is neither linear or exponential. Neither linear or exponential. Okay. How about the third one? You have 12, 3, 6, and 4, 3. Okay, let's check the difference. 6 minus 12, that's negative 6. 3 minus 6, that's negative 3. So the difference is not common. So this is not linear. How about the ratio? 6 over 12, that's 1/6. Right? By 2. And then 3 divided by 6, that is 1/2. Wait, here. This is 1/2, sorry. Not 1/6. That's why I was looking at it. Something's wrong with me. They have a common ratio. So they are exponential because the ratio is common. Right? That's it. Okay. Let's have problem number 3. Ethan is playing a new game on his phone. After successfully playing his first game on one day, he was awarded with 25 diamonds. The game then rewards him with 3 diamonds for each consecutive day he plays after day 1. Determine if the number of diamonds he has after n days of consecutive play is linear or exponential. Okay? Linear or exponential. Now remember, to determine whether the given problem is linear or exponential, we need to check the situation if it represents arithmetic or geometric sequence, since it is day by day, consecutively. Okay? So, to do this, we should determine if there is a common difference or a common ratio. So, what happened is the number of diamonds increases by 3 each day. So there is a common difference of D, common difference, which is equals to 3. Therefore, the this problem involves a linear growth. the growth here is linear because it says each day. Okay? This answers the question. Determine the number of diamonds Ethan will have after playing 6 consecutive days. So we can use the formula for the nth term of the arithmetic sequence. So that formula would be a sub n would be a sub 1 plus the common difference, then n minus 1. So to write the explicit rule in this function notation, the model that models this situation. So first, we find the explicit rule for this number of diamonds Ethan gets each day on his game. So let's say a sub n, a sub 1, he started getting a 25. That would be our a sub 1. Alright, the common difference is 3. Then n minus 1. Okay, so we are trying to get the explicit rule for this. Okay, so we have a sub n is 25. Distribute, this will be 3n minus 3. A sub n, 25 minus 3, that is 22. And this will be our explicit rule. So we can use the explicit rule to find a sub n. So that means a sub n, n is 6, would be 3 times 6 plus 22. That would be 18 plus 22. A sub 6 is 40. And this is the number of diamonds. Okay? Ethan will have 40 diamonds for, okay, I will have Ethan will have 40 diamonds after 6 days, on the 6th day. Okay, we can see that on the sixth day. Find the number of consecutive days Ethan will need to play to earn 160 diamonds. Okay, so we can use the rule for the part B, a sub n, the explicit rule. What's the rule? 3n plus 22. To find the number of days, it will get an a sub n of 160 diamonds. That's a question right there. Okay. Now, we will apply the idea of using the explicit rule. A sub n 3n plus 22. So we have a sub n is 60, 3n plus 22. So 160 minus 22, that would be 3n. So 160 minus 22, that's 138. So n will be 138 divided by 3, n is equals to 46. So Ethan, it will take, because it's asked how many number of consecutive days, so it will take Ethan 46 days to earn how many diamonds? 160 diamonds. Wow, it's good about talking some kind of diamonds right here. It's nice to know. I hope it's real diamonds. Okay, let's do this. All right, let's do this problem. A ball is dropped onto the ground from a height of 8 meters. On each bounce, the ball reaches a height of 60% of its previous maximum height. So determine the height of each bound. It can be represented linearly or exponentially. Actually, if we try to visualize what is going on here, there is a ball that is dropped at a certain height. So when it dropped here, it bounces and then it goes to another height. So the ball is somewhere here, it bounces. So if this is the height, this height should be 60%. It says 60% of the previous maximum height. So this will be 0.6 of the height. Then it bounces again. As soon as it reaches here, it bounces. Then this height here will be 0.6 of the 0.6 of the height. And so on and so forth. 60% each time until the ball stops bouncing. And that's the situation right there. So to identify whether the given problem is, this problem is linearly or exponentially, we should determine if the situation here, it represents an arithmetic or geometric sequence. So to do this, we should determine the common difference or the common ratio, as what we did in the previous number. So in this problem, the height of the previous bounce multiplied by 60% to get the next height. So the ratio, there is a ratio of 0.6. And the sequence is, since it's ratio, the sequence is geometric. And how does geometric similar? It's similar to exponential. All right? So therefore, it is exponentially. All right. Determine the height that the ball reaches after the fourth bounce. So let's say here it bounced 1, it bounced at 2, 3 bounce, 4th bounce. 4 times. So we determine the height of the geometric with a common ratio, using the common ratio here of 0.6. So we know that the ball had an initial height of 8 meters here. That's the initial height. So the ace, when it's 0, it's 8. So we will be using 8 sub 0 as the initial height. we're going to use this as the initial height. Occurred before the bouncing. The first bounce and n represent the number of bounce. Okay, so to find a sub 1, we can multiply with a common ratio. So we're going to start with a sub 1 here would be a sub 0 times r. That's the recursive rule. So a sub 1 will be a sub 0 is 8 times the ratio, which is 0.8. So a sub 1 is 4.8. So we evaluate that by using multiplication, 8 times 0.8. Now we know that the first term, we can have an explicit rule to find the height of the fourth bounce. So that means n, fourth bounce. So n here is equals to, n is 4. So we can have a sub n, that's the one we're looking for, 4.8 times the ratio, this time it's 0.6 of the height, which is 0.6 n minus 1. So if n is 4, we could say a sub 4 will be 4.8 times 0.6 to the power of 4 minus 1. Substitute the n4 there. So a sub 4 would become 4.8 times 0.6 to the third. So let's gonna use the calculator to get this value. A sub 4 will be approximately, when we have some decimals, 1.0368. Okay, so the height, all right, we have the height of the fourth bounce will be 1.0368. This, you must do this, have your final statement when you are solving problems. Be sure in your final answer you answer the question. That's the most important thing that you have to remember, and you're not gonna miss if you will be doing that. Okay, let's have problem number 5. Mr. Brust has been collecting He-Man figures for 40 years. Wow. The number of figures he owns can be modeled by arithmetic sequence. Okay, it's indicated here that it will be modeled by arithmetic sequence, where the first year is year 1, and the number of figures in year 5 is 12, and the number of figures in year 20 was 167. So how many He-Man figures he have in the year 14? Right. If we try to have that, it says arithmetic, where the first year is year 1, and the number of figures in year 5 is 12, and in year 20 is 167. The question is, what would be in year 5 is 12, in year 20 is 167. How many did he have in year 14? So 14 is a March year. How many does he have in that year? Okay. So maybe we can do some getting the difference here by using the formula of slope, because this is an arithmetic sequence. So there is a similarity in linear function in arithmetic sequence. Okay, so we have the formula when we use that y equals mx plus b. We are trying to get the slope to be how it is similar in a sub n equals a sub 1 plus that difference times n minus 1, that value right there. So if we are trying to get the slope, it's just the same as getting the common difference. So let's do the slope. That would be y2 minus y1 over x sub 2 minus x sub 1, wherein we can have, okay, I can blow this up. Y sub 2 can be 167 minus 12 for y1 over 20 minus 5. Okay, so 167 minus 12, that's 155 over 15. So reducing by 5, we have 31 over 3 as the common difference. So this will be our d, the d that we have. So in other words, we're gonna find a sub n. So what's the difference of having 5 to 14? All right, it's gonna do this. A sub n, let's say we have our, I'm gonna use the 12, 5 and 12 here, the first one. So if the first He-Man that he has in 12, in 5 year, in year 5, so I could have a sub n is 12 plus the difference 31 over 3 times n minus 5. I could have that as the rule. Okay, so how about a sub 14? What would that case be? That would be 12 plus 31 over 3 times 14 minus 5, which is a sub 14, simplifying, that would be 12 plus 31 over 3 times 9. 14 minus 5 is 9. So we cancel this out. 9 by 3, that is 3. So a sub 14 is 12 plus 31 times 3, that is 93. So a sub 14 will have 105 He-Man after 14 years. So 105 he will have 105 he-men after 14 years. Okay. We have it. All right. The third term of the sequence is 5. Okay? The first term is 20. I think we're gonna have, I'm gonna write it here. So, of the following, which statement is true? Okay, before making your choices, do an inspection of your choices. So the A and B are talking about a sequence that are arithmetic. C and D are talking about a sequence that are geometric. Okay? Arithmetic and geometric. All right, I think I have to check in how it looks like when it's written that way. I could have, let's say I'm gonna write it here, arithmetic. In arithmetic, let's say this is my sequence right here. First term, second term, third and fourth, and fifth term. And what is given only in third term, you have 5. On the fifth term, you have 20. Okay? So if we look at this, let's say if I subtract 20, I'm looking at the difference. If I subtract 20 minus 5, I want to know how much would it be on the fourth term. So if I subtract 20 minus 5, that's 15. So 15, I divide it by half because 4 is between 3 and 5. The term is 7.5. Okay? So this is 7.5 right here. So what did I do? If I divide 5 by 2, I will have negative 2.5 here. Do backwards. Then negative 2.5. Alright. Also, wait a minute. I have to, so the difference here is, oh, wait, I think I mess up. Can I make this bigger, move a little bit? That's why I messed this up. So 4, 5, this is 20. So the difference is 7.5. So this will be 20 minus 7.5. That is 12.5. Okay? Alright, so 7.5, move backwards in order. You have 5 plus or minus 7.5. You're gonna have negative 2.5. A negative 2.5 minus 7.5, you have a negative 10 for that. Okay? So you try to look for what's going to happen if you have a geometric. So let's say, does this answer the question? The first term could be negative 25. This is wrong. We're looking at the arithmetic. If the sequence is arithmetic, the fourth term is 7.5, wrong. So what we have left is the geometric. Okay. Now let's do the geometric here. Gonna write I have 1, 2. So what we have here, 4 up to 6. So we're gonna check 3, 4, 5, and 6. So what is given? We have on the third term is 5, and the fifth term is 20. Take note that in getting a ratio, we could easily get the ratio by dividing 20 minus 5, because we can do that. Even though there is a space, okay, I have, there is a space between 5 and 20. Okay, so if I say the ratio is 2, it's 4, I mean. 20 by 4 by 5 is 4. All right, so there is a space in between here to have the ratio to 5 to 20, which is 4. So when we try to check 20 divided by 2, because it's half of 4, then we could have 10 here. Then 20 by 2, okay, 10 by 2, then this is 5 by 2. So what number when you multiply or divide 5 divided by 2, that would be 2.5. I think I don't need this. And 20 by 2 for sixth term would be 40. Because everything is given, it's not being asked in letter C and letter D. I should stop. So that means if the sequence is geometric, the fourth term is 7, it is not. If the sequence is geometric, the sixth term is 40. Sixth term is 40. It is correct. All right. By doing that, by getting the common difference and common ratio, then you could easily get the answer for that. Let's have this problem. Mr. Bean has a lot of siblings and lots of nephew and nieces. The number of people in his family can be modeled by a geometric sequence, where the first term in generation 1 is 50, it's 1. The number of people after generation 2 is 52, and the number of people in generation 4 is 468. How many people will Mr. Bean have after the generation 6? Okay. So what are we gonna do here? Let's write it down. So it's 1. I could start writing when the people in generation 2 is 52. Then the generation 4 is 468. What will be in generation 6? And it is geometric. All right. So what are we going to do with that? Let's think about something else. By doing this, we could say, let's look at it's geometric. So are we getting the ratio here? Or are we getting the common? Oh, it's not a common difference because it's already said that it's 468 on the fourth term. So maybe we could get the ratio by using, about when it's 468, you have 52 to get the ratio. Right? Or we could do 468 at once divided by 52. Anyway, we could do this. 468 divided by 52. So you have an r cubed. So 468 divided by 52, that's 9. I mean r, not r cubed, that's r squared. What's going on? So that would be r squared. So r is the square root of 9, which is equals to 3. Since we are looking for, this is geometric, so we can use the g of n, which is a, you can have a sub 1 or a sub 1 r to the power of n. Let's do the shifting, n minus 2, because we have by 2, 4, 6. All right. So we could say 52 times the ratio, and that would be n minus 2. So g of 6, that's what we're looking for, is 52 times 3, 6 minus 2. So g of 6 is 52 times 3 to the power of 4. Multiplying this in the calculator, we have 3 to the 4 times 52, 4,212 people in the generation 6. Okay, let's do this. Okay, let's have this. It is known that f of x is exponential and linear function, and that it passes through the given points. We have the first one, 8, 12, and 10, 6. Okay, let's gonna do this and check. Do the linear and do the arithmetic. Do the exponential. Why I keep on saying arithmetic? Okay. All right, let's gonna do this. I start with 8, 12, and 10, 6. I'll do linear here. All right. So if we have the formula using the y equals mx plus b, related it to y equals a sub n equals a sub 1 plus d times n minus 1. So might as well, since there are 2 points here, if this is x 2, x1, y1, I mean, this is x2, y2, I can get the slope here by using 6 minus 12 for the y2 minus y1 over x sub 2 minus x sub 1 here to get the slope. So 6 minus 12, that is negative 6. 10 minus 8, that is 2. So the slope is negative 3. I think that's it that we have to look. So we could do y minus 12, y2 minus y1 equals negative 3. We are just asked to write an equation, right, for its function. So the slope would be negative 3, x sub 2, or x minus 8 for the first one. All right. Or you can have y minus 6 for this would be equals to negative 3 x minus 10. We're using this point. So for that 2 equation. All right, that's for linear. All right, how about the other one for linear here? So I'm going to do the same thing. x1, y1, x2, y2. All right, so let's get the slope. Would be 40 minus 5 over 8 minus 3. So you have 35 over 5. That's equals to 7. Okay, so you could say that, okay, 7 is the slope. So you could say that y minus 5 over x minus 3 equals 7. All right. So if you say y minus 5 equals 7 times x minus 3 for your equation for arithmetic, linear. This is linear. So for linear, for this, you can have, for this point, you can have y minus 5 equals 7 times x minus 3. Or by doing this coordinate point, you can have y minus 40 over x minus 8. So that would become y minus 40 equals 7 times x minus 8. That's for equation for the linear for these two numbers right here. Okay, how about the geometric? The exponential. I keep on saying geometric. All right, let's do the exponential function. 8, 12, and 10, 6. I will get the ratio between the two. 6 and 12. This ratio. So I could get 6 over 12. That would be 1/2. So by doing the ratio, I could write the function as y, using the 8 and 12. That would be r, because that would be r squared. Sorry for that. That would be 8 times r to the second power, right? Or any r to the power of x. I will use an x here. So that means we can have y. I'm using the coordinates 8 and 12 here. I would just have 12 times r is 1/2, so that would be the square root of 1/2 for r squared. So 1/2 to the power of x minus 8. While for the 10, 6, I will have y equals 6 times the square root of 1/2 to the power of x minus 10. This is exponent shifted. Shift to 10. X is shift to 10. Okay, let's have the second one. 3, 5. So I could use... Okay, I get the r squared for 40. I could use 40 divided by 5. That's 8. So r would be the square root of 8. So y could be written, if I have 3, 5, y could be written as 5 times the square root of 8 to the... It shifted to 3. If I have 840, y is 40 times the square root of 8 to the power of x minus 8. And that should be the case right there. Right? And then this is to the 40. That would be r to the 5th power, 5th root. So we have 5 and then 3, 8. If you try to look at the 3, then to 8, we have 5 to 40. So how many ratio do we have? 3 to 5. Let's say it's by 1, 3, 4, 5. Okay, it's 5 spaces. So it will be the fifth root, r to the fifth. So that would become here. Remember when we did that? So we could have like 40 times r times r times r. How many times to get into an 8? Because this is the 8 here. So what are you multiplying? How many times you multiply for that? Okay, x times 8 to the power. That's it. And that would be all for this problem. All right. So let me say this. If I can do it, so can you. Please don't forget to like and hit the this subscribe button. See you in my next video.